Let us now take a look at Python scripting. First, we will embed the Python interpreter. We will create an embedded module for scripting. We will take a look into how we can load Python scripts from disk. And in the end, I will show you how you can distribute your application. Alright, so first we have to include the pybind11 embed header. Now we can create a scope interpreter, which will load up the Python interpreter. And from this point on, we have access to the Python environment and we can run Python scripts. So in order to execute a Python script, we have to use the exec function. And here we can write hello world, I run it, and it prints hello world. Let's now write an embedded module. For this we have to use a macro called pybind11 embedded module. We have to provide a name for the module. I will call it embedded module. And again, as the second argument, we receive a module which we can use to expose C++ to Python. Let's give the module a name. Let's create a simple function where we just print something to the screen. I'll call it say something and print say something to the screen. Now I have to expose it to the Python embedded module. Like in the previous video, we have to use the def function. We have to provide a name and a function pointer. Now that we have created the embedded module, we can import it into our Python environment. And let's call the say something function on it. And this embedded module can also be accessed from Python scripts which are on the disk. So everything we execute inside this Python environment has access to the embedded module. And it's not like it is just quote unquote statically compiled into it, but you can also change the C++ state. You can create a static variable. And we will expose a function which changes the static variable inside the C++ world. Our module is loaded. We can use it to set the counter. We set the counter to 10. And now, as you can see, the counter has been set to 10 through Python. So this embedded module is some sort of a bridge between the Python and the C++ environments. Okay, let's now take a look into how we can load Python scripts from the disk. Let us take a look into where our Python environment is running from. For that, we have to print out the system path. We can get it by importing the system module, and we can use pybind11 print to print the attribute called path. As you can see here, the system path is set to use my locally installed Python version on this computer. In the last part, I will show you how you can change this so that it will load up the Python distribution you provide with your application. But for now, we can leave it at that. And also we can see here the current work directory of the program, so it is running out of the debug build folder. So the scripts we want to load have to be placed inside this debug folder. And just for convenience sake, I won't be playing around with the system path, but so that you know, you can also append your custom folders to the system path, and then it will look also inside these folders. But for now, I will just place the Python scripts I will be writing inside this folder, and it will be able to access the embedded module. I created a Python file called hello.py inside the debug folder, and now inside of C++, I will just import this module by using pybind11 module import, and I give it the file name, and it prints out hello py loaded. This is something I have written inside the Python file, so as you can see here. And I have placed one more script, and I have created a directory and I placed another script inside there. So you can just use a regular Python import and it will automatically resolve the import statements. As you can see here, it has loaded up all the Python files I just specified here. And inside this script, we can also import the embedded module, and we can call the say something function we defined, and it prints say something. We can also change the counter from here. Set counter 20, and now here and take a look into it, it will be set to 20. So this is a way you can use Python as a scripting solution for your application. Let us define a function inside the Python script, which we will be calling from C++. Let us just print the value. So this function will be defined as an attribute on this hello world module. So we can retrieve it by saying hello module.attribute, and it is called magic. And now we can just call it as a regular function, and we can give it something we want to print. We give it a floating point value. We execute and it prints 5. We can also give it something else, a string, and it will print the string to prove that it's a string. And we can also pass it some user-defined data. I will create a data struct called myData, and I will also expose this to the Python embedded module. So, and here I will create one of those. So it will be 33, and I will pass it like so. We will change this to myData, and we know that it is a myData type. We will just print out the X, and we will pass it in like so with a reference. We run it and it prints out 33. So we can also give it some type hints. For this we can say the following. This is myData, and it still runs the same. So I'm now in the debug folder, and I can run the pybind11 app we just created, and it prints out everything correct. What I will do now is I will uninstall Python, and then we will take a look at what's going to happen when we open up this executable. This is my Python version right now, and I will remove it from my system. So here I'm uninstalling it. Version, it doesn't say anything, and if I run the application now, it's gonna complain because it cannot find the Python 37 DLL. To solve this, we can do the following. We can go to the Python website and we can download the embeddable zip file. We can take a look into what's inside, and here you see it has the DLL, and it has a zip file called python37.zip. You need both of those files. We extract it next to the executable, and now we will run it again. As you can see now, the program works as previously, but now it uses the Python distribution we provided it with. And that's pretty much it for this video. Next up will be the setup process for Visual Studio for the debugging of Python and C++ mixed language code.